Hey everybody, so alright, in this video I'm gonna do a problem on projectile motion, and let's just get right into it. So we're given that a diver is running and then jumps into the water as shown in this figure. So the diver has initial velocity in that direction, in the x direction, and then so we're being asked to find her initial velocity that'll take her just to the point where the cliff meets the water at this ledge right here. So in essence, the projectile is going to look like this. So we want to know what's the initial velocity in the x direction needed that'll take her to this point just safely and meeting the water without hitting anything. So to begin with, let's jot down whatever we know in the x and y, in terms of x and y. So for x, we know that the displacement is going to be 7 meters from where she starts. So that's a distance of 7 meters. So x minus x0 is equal to 7 meters. We know the acceleration due to gravity in the x direction is 0, because always in projectile motion there is no acceleration due to gravity in the x direction. There is acceleration due to gravity in the y direction, but not in the x. So we know that as well, and that's it for the x. Remember, we need three knowns to find one unknown using one of the 4 kinematical equations that I had a video on that previously, just before this one. Okay, so that's it for the x, and anything that we know in terms of y, that would be, okay, the y displacement is 9 meters, so y minus y0 is equal to 9 meters. What else do we know? We know acceleration due to gravity is equal to 9.8 meters per second squared. What else do we know? We know that the initial velocity in the y direction is 0. Y is equal to 0. And that's it. All I need is three knowns to find the 4th unknown. Because we also, ultimately our goal is to find the 3rd known for the x. Because our answer we want to know what's the initial velocity in the x direction. But that's an unknown. So we need 3 knowns to find that unknown. Let's just write v0x, which is what we want to find. Okay, so we could find time here, because time is the same for both. Notice that we're finding one unknown that suits both. See, displacement is different for y and for x. Same as for acceleration, same as for the initial velocity, but one thing that we could use for both is time. So time for y is the same as time for x. So let's find time using the 3 knowns for y, and then use that into x. That way we would have 3 knowns, and then we would ultimately find our goal, which is finding initial velocity in the x direction. So we could use any of the 4 kinematical equations that has those 3 knowns with that unknown, and the best equation for this would be y minus y0 is equal to v0y times time plus a half ay t squared. It's one of the 4 kinematical equations. So y minus y0, is just plug in what we have. So 9 is equal to 0 for v0y, which makes this entire 0, plus a half times acceleration due to gravity, so a half times 9.8 times t squared, which is what we want. So 9 is equal to, this right here is 4.9 t squared. So we divide on both sides to isolate t. So divide by 4.9, divide by 4.9. And so using the calculator, 9 divided by 4.9 is 1.84. So 1.84, so 1.84 is equal to t squared, square root. So then we get right here, t is equal to the square root of 1.84. That would be 1.36 seconds. Okay, so that's time. Now we could use this time into here. So now finally we have three knowns in terms of x. So we could find our v0x. Okay, so we could use any of the four, well, the best of those four kinematic equations, and that would be, let's see, that would be, I guess it would be the same one that we used for y. So x minus x0, which is 7 meters. Okay, so 7 meters is equal to v0y, or v0x in this case, which is what we want. So v0x, and then time we know, which is 1.36, and then plus the acceleration is 0. Acceleration due to gravity is 0, so that would completely block out, become 0. And then we're left with 7 meters equal to 1.36 seconds times v0x. Just divide on both sides. And so we should get, let's see, 7 divided by 1.36, and that is our answer. So v0x is equal to 7 divided by 1.36, which is equal to 5.147 meters per second. And that's the final answer, and that's how we used kinematics to find the solution to this problem.